All right, so a couple things to look at here in terms of surface area and just reviewing real quick. We've got just some easy stuff to start with here. I think you can do this without too much extra help from me. Right, length times width for square or just side squared. Right, one side of a paper napkin, 10 centimeters by 10 centimeters. You'll go 10 times 10 and you get 100. Okay, length times width for a rectangle, same idea. What's the surface area? Okay, circle pi r squared. One side of a clock face, which is 15 centimeters across, or with a radius of 15 centimeters. Remember that, there we go. This little r here, that means radius. All right. A rectangular prism. So they give a formula here that's a little bit strange. This works. It is not normally the one we've kind of used for a rectangular prism, but you can do this if you want. So 2 times the area of the base, that gets you the top and bottom, plus the perimeter of the base, which is the total distance around, times the height. Okay, that will work. It's just the way the formula shows up is a little bit weird. Right, so this is one. You can use any method you want. You've got a tissue box or Kleenex box, 25 centimeters long, 12 centimeters wide, 12 centimeters high. All right. If you wanted to look at this, you could say, well, there's going to be 4 rectangles that are 25 centimeters by 12 centimeters and 2 squares that are 12 by 12. Okay, that's the other way to look at this one. Okay, so see if you can figure that one out. You're going to need probably an extra piece of paper to show some work there. Cylinder, again, here's a formula, 2 pi r squared plus 2 pi r h. R again standing for the radius, h standing for the height. So candle, 15 centimeters high and 8 centimeters across. Remember this 8 centimeters across, that is the diameter. And the diameter is the same as a radius times 2, or radius is equal to diameter, which is that 8, divided by 2. Alright, so in this case, the radius for this particular cylinder would be 4, and you'd use that in both. And then, again, show your work on a separate page. Usually it's easier to find out what is 2 pi r squared. So 2 times pi times radius times radius. Write that number down, and then find out 2 times pi times radius times height. Write that number down, and then add the 2 of them together. Okay, triangle 1/2 times the base, or times the height, or base times height divided by 2. Right, that works too. It does this? It mathematically is the same thing. Yeah, so a couple hints for the first page, anyways. Base times height divided by 2. That's what you're doing mathematically, anyways. There we go. Okay, let's move on here. Define surface area in your own words. So that's just I don't mind if you just talk about that between the two of you. Figure out what needs to what that term means for you. Make sure obviously you're both on the right track with it. All right. Then you've got 2 containers here. We have a tomato soup can and an orange juice box. And your question for you, given that they are not really to scale, maybe? Don't think they're close. Which of these 2 has the greatest surface area? So you can make a prediction first. And then, it's not going to be that easy that you can just pick one and it's a 50% chance to get it right. How much more surface area does one have than the other? So you're going to actually have to find out surface area of the tomato soup can, surface area of the orange juice box. Don't worry about the straw going to the side here. And then you're going to say, oh, okay, well, one of them is bigger than the other. Bigger subtract smaller, that is going to be how much more surface area. That's what you're actually going to figure out there. Okay, so again, if I'm looking at this, I'm going to say, well, I've got 2 sides that are 8 by 5, right? The top up here and the bottom that we can't see. I have two sides that are 14 by 5, this side here and the one in the back that we can't see. And I have two that are 8 by 14, this one here and then the one on the back that we can't see. And add them up. And here again, I've got the top and the bottom, so pi r squared gives me the top, times 2 gives me the top and the bottom. And then 2 pi r h gives me the side, once we imagine that we roll that out. All right, so go ahead and do that one. Moving along. Right rectangular prism. So gives you a little bit of a question, and then says if you double the height, what is the new surface area? So if the height, instead of being 6, suddenly becomes 12, how does that change the surface area? It's a kind of an interesting idea to think about. What if I double one of those? What does that do to the entire surface area? All right, so obviously the 5 centimeters by 10 centimeters, the top and the bottom, that doesn't change, but each of the other 4 faces does change. All right, so here is Silvio wanting to cover the stairs to his basements, 14 treads or steps and 14 risers. Okay, so this picture is not of the entire set of stairs, it's just giving some of the stairs. Each step is 90 centimeters wide and 24 centimeters deep. That's front to back. Each riser is also 90 centimeters wide and 18 centimeters high. Diagram shows some of the stairs. All right, so now we're going to actually have to go up here to find the question. Nope, go down here to find the question. What is the surface area of the step treads? So the treads are the part that you walk on. What is the surface area of the risers? Those are the area that you would stub your toe on. And then what is the total surface area of the part of the stairs Silvio plans to cover up? So all 14 treads and 14 risers. Okay, figure them out, add them up. Not a super hard question, just lots of weird numbers to look at and lots of writing, so just make sure you read carefully and answer the questions as they call it. They're actually trying to be nice to you here, because once you find out the surface area of one step, how many of them are there? Well, there's 14. How many risers are there? Also 14. So 14 times the area of 1, 14 times the area of 1. Take your answer for A, your answer for B, add them together, you get the answer for C. All right. Great Pyramids at Giza, Egypt are one of the greatest engineering accomplishments ever. The largest pyramid is 146.7 meters high. The length of each side of the square base is approximately 230.6 meters. Okay, show all your answers to the nearest tenth. So this is the first one, is easy. It's a square base. What is the surface area of the base? All right, so in this case, okay, yeah, you can do that. Now, right, length of each side, so length times width, 230.6 times 230.6, round your answer to the nearest 10th. Surface area of each triangular side. This is going to require that we do a little bit of work with this one. So I'm going to, I think I have space. Yeah, I got some space down here. I'll kind of just, if we were to draw one of those sides, each of the 4 sides is going to be a triangle. Something like this. Now we know the height of the pyramid, but we don't know currently this distance, the height of the triangle. Right, this is like the slant height of the pyramid, if you will. Alright, so you're going to have to do a little bit of work to figure that out. Again, if we were to look at a top view of this pyramid, here is my point at the top. Alright, we need to find out what is the height of one of these triangles. So your job is to now figure that out. Alright, once you want to figure that out, it's going to require a little bit of thinking here. I drew you before. Oops, and it went away. So let me draw this again. First of all, actually, let's look at a side view of this pyramid. Okay, so we've got the whole pyramid here. And if we're looking at it directly from the side, it's going to look just like a triangle. Now, what we want to know, we know that the height of the whole thing, according to our question, right, is 146.7 meters high. We also know that the entire distance across here is 230.6. Now, if I look at this, I need to know what this slant height is here. If I know that this whole distance is 230.6, half of that distance is going to be 230.6 divided by 2. This is a right angle triangle. I know, let's call this A. I know this B. I have a Pythagorean formula that allows me to find out what this is. Once I know that, I can figure out the area of my triangular face, right? Go with that. All right. Remember that there are 4 triangular faces. Add them up, and there you go. We've got a rectangular box with a tube running through it. Okay, so here we've got not only the rectangular box, okay, so 4 sides that are 14 by 20 centimeters. Then we've got these faces on each end that are 14 by 14, but they've got a little hole missing out of them, right? So we're going to have to find out the area of that circle, pi r squared. We'll put that by 2. That gets subtracted from our 14 by 14. Right, so we've got 4 rectangles, 2 squares, and then subtract the circles. And then we got to add the inside part of this weird cylinder thing. So that's we figured out, okay, imagining the sides of a cylinder are 2 pi r h. Right, well, the h is going to be just the length of the whole thing. So that's 20. The radius is 2. Pi is pi. 2 times pi times the radius times h gives us that middle inside part, those walls that are part of the surface area. So again, we will have 4 rectangles. We're going to have 2 squares minus 2 circles. And we're going to have this 2 pi r h, the inside of the tube. So these 4 plus the 2 squares minus, it's supposed to be an S, not it looks like a 5. I'm struggling here apparently. Sorry. 2 squares minus the 2 circles plus this 2 pi r h, and away we go. Have fun. And finally, this has been constructed from centimeter cubes, calculated surface area. Not too super hard, but go ahead and do this one. If the length is increased from 5 cubes, so it's right now it's 1, 2, 3, 4, 5 cubes long, to 8 cubes long, what is the new surface area? So go ahead with that as well. Have fun!